Hi students, welcome to today's video. Today we are going to start with precedence and associativity of operators. So from the previous class, we have learned so many operators such as arithmetic, relational, logical and so on. So each of these operators has its own precedence and associativity. Okay, so let's see what is meant by precedence and associativity. So precedence, simply we can say priority. Okay, that is the meaning of the word precedence, simply priority. So every operator has its own priority and precedence. If you consider an expression, mathematical expression, in a single expression there may have multiple or more than one operators. So we may need to confuse which operation we have to perform first, such as do we need to perform addition first or subtraction first. Like that, we may be confused, isn't it? For example, you may know the Bodmas rule, isn't it? The same only, the same board in Bodmas rule, we will perform what multiplication first, isn't it? So like that, here each operator has its own priority. That is meant by precedence. Okay, and there are different levels of precedence. We will learn each one. Then, if you consider the term associativity means, suppose in an expression there are multiple operators which has same precedence. So how which operation we will evaluate, isn't it? So for example, let me write here. uh, let it be a divided by b multiplied by c. Okay, so if you consider both these operators has same precedence, isn't it? So if you look at this table here, you can see a table. So from this table you can okay, see, from this table you can understand. And what multiplication, see here multiplication and here division, both has the same priority, isn't it, or same precedence. So here which operation we will perform first? So we have two options: either we can divide a by b, or first we can multiply b by b into c. We can perform the operation b into c. So we will be confused. So in order to remove, or in such a situations, we can check the associativity. See here both operators has the same priority, so same precedence and priority. So what we will do, we will check the associativity which is from left to right, isn't it? So what we will do, we will start evaluating from left to right. Okay, so we will perform this operation first, then that result will be multiplied with c. That's how the associativity is evaluating. Okay, I hope you could understand. Here in this table you can see several operators such as arithmetic operators, conditional operators, logical operators, isn't it? So you can just go through all these examples. Okay, so for example, here we have relational operators, then unary operator may be here unary operator, then addition and subtraction operator. Okay, then concatenation operator, then multiplication and division operator, and its corresponding precedence is given here, and its associativity is also given here. Okay, I hope you could understand what is precedence and associativity. Okay, then let's see some example. And let's take an example of the following expression, which is a minus b plus c. See, if you notice here, you can see a minus b plus c. How many operators are there? One and one, two. Okay, two operators are there: arithmetic subtraction operator and arithmetic addition operator. Let's check the precedence of arithmetic operators. See, addition and subtraction operator has same precedence, which is 5. Okay, then what is its associativity? That is left to right. So we can check how to solve this expression. See, precedence of both operators are 5 only, isn't it? Both subtraction and addition has the priority 5, and associativity is left to right. So if both are same precedence, we will check the associativity. So what we will do, we will first perform this operation a minus b. Suppose a minus b is 5 and c has the value 6. What we will do, the second operation will be 5 plus 6. So 11 will be the result. So like that we can apply associativity and precedence. So I hope you could understand. And here there are one more example. A minus b plus c will be evaluated as a minus b plus c. See here what is the additional operator, which is a parenthesis, isn't it? So it's like a parenthesis. It will evaluate like a parenthesis. See, parenthesis has the first precedence, isn't it? Precedence once. So in this example, whatever we have written in the parenthesis will be evaluated. So a minus b will be performed, then that value will be added with the c. The same will happen here because of the precedence and associativity, isn't it? So if you perform b plus c first, that is wrong. Okay. So I hope you could understand. And another example, system.out.println. You are familiar with the SOP, which is a print function. It will print the argument. Okay. So let's check how it will work. Then 6. What is 6? So here a string is there, 6. 6 is a string. Then plus 3 plus 3. Okay. So here this plus 3 will act as a concatenation operator, isn't it? So it's string concatenation operator. And the next operator will be, so this first operator which is written here. Okay, let me note down. See, this is the string plus operator for concatenation, and this is the arithmetic addition operator. So for both operators we are using the same symbol, which is the plus symbol, isn't it? So you don't need to confuse. Here why it is a concatenation operator, because see here we have a string value, that's why it is written in double quotes. Okay, so in order to concatenate, or in order to join this 3 with the 6, we are using this plus concatenation operator. Okay, so according to the priority, let's check the priority of both operators. Which are the operators for string concatenation and arithmetic addition operator? Probably both have the same precedence. And string, okay, here string concatenation and arithmetic addition operator has the same priority, which is 5. Okay, so if in an expression there is same precedence operators, what we will do, we will check its associativity also, which is left to right. So here based on the associativity we will perform the operation. So 6. Okay, so 6 6 will be 6 will be concatenated with 3, isn't it? Why? Because this one and this one has same priority, which is 5, and so both have the same priority, so we will consider associativity, which is left to right. So then we can concatenate this operation, we can perform this operation first. So result will be 6, there is a space, this is space, so space 3, isn't it? Then after the arithmetic addition operator, so here it will work as a concatenation operator. So 6 3 will become, after concatenating 6 3, this will become also a string. A value added to the string will also a string. So this will here work as a concatenation operator. So 3 will be added here. So this will be the result. Okay. So but as you think, it will not add 3 plus 3 first. Like here it is written 6 space 6, that will not happen. So 6 space 3 3, that is the right answer. Okay, then we have one more example. Here what is in SOP? SOP 3 plus 3 plus 6. So here what is, this is arithmetic addition, this is string operator. Both has same priority, which is 5. So we have to check for the associativity, which is from left to right. Okay, so what will happen? So addition should perform first, which means 3 plus 3 6. So this 6 will be concatenated or joined with 6. So 6 this space 6 will be the answer. So this will be the output. Okay. Then one more example is here. Okay. Then SOP 6 space then concatenation then in bracket 3 plus 3. See here the priority of the bracket will be considered. Okay, also considered. So we can check the what is the priority of that parenthesis or bracket, which is 1, and parenthesis priority of addition and subtraction will be 5. So what will happen? Which one will perform first? Of course, priority will goes to the parenthesis, isn't it? So which one will be evaluated first? What is given in the bracket will be evaluated, which means this 3 plus 3 will be evaluated, which will be 6. Okay, then that 6 will be concatenated with this string value. So what will be the result? 6 space 6. Thus that space is given in the double quotes. That's why. See, if there was no space, double quotes would have been here, but double quotes is here. So that's how we are checking or evaluating the expressions. Then write a program 5.14. Write a program to demonstrate associativity of operators. See here you can see what is the output. 6 space 3 because this according to associativity left to right both has the same priority. Then here also both has the same priority, but 3 plus 3 will be performed first. That's why 6 space 6. Then here we are using at the last line we are using what parenthesis. So what is given in the parenthesis will be performed first. Okay. So next we are going to learn the new operator. So students, new operator is an operator which creates objects. So you might have learned this, you might have heard this word object, isn't it? Object means simply physically existing something, isn't it? That is object. For example, watch is an object, table is an object, book, then what else? Smartphone, human, all these are object. Each object has its own property, isn't it? Its own property and behavior. So let's consider a smartphone. So a smartphone has several properties. Which are the properties? Its color, weight, model, number. Let's say IMEI number. Okay. Then brand. These all are the properties of a smartphone. And if you consider the behavior, it can we can make a call, isn't it? So it's possible to make call, end call, watch video, play games. These all are the behaviors of an object. Okay, so this new operator can create an object. Okay, so use of new operator is to create an object. I hope you could understand. We actually missed the we actually skipped the third chapter. I think in third chapter we are learning classes and object concept in detail. Okay, so that chapter we skipped in this first time. So then also you can understand this new operator. Simply it's create. Using the new operator we can create the object. That is the use of new operator. Let's see how. Okay students, normally how are you creating a variable? For example, int c. Okay, so int c is a variable of type int, isn't it? Similarly, char b is also a variable of type char. Float c, so here c is a variable of type float. Similarly, we can create, suppose there is a class here and there is a class called mobile. So we can create a variable m of mobile type. Okay, so this variable m is of type mobile. So in this variable we will store the address of the object. So how can we store the address of the object? So in order to store the address of an object, we need to create the object. So how can you create the object? Using the keyword new or using the operator new. Then new class name. Okay, will create the object. Here instead of this class name, what can we write? We can write the class name itself, isn't it? What is the class name here? Okay, what is the class name here? Mobile only. Okay, so this will create, so this new operator will create an object in the memory. Really that object is existing, isn't it? So that object, that address of the object, not the object, address of the object will be copied to the variable m of mobile type. So I hope you could understand now. Okay, so that is the class variable using the new operator. Here you need to understand new operator. New operator creates an object of class type, then address of that object will be stored in the variable m of class of mobile type. Okay, then if you look at this figure 5.6, it's a schematic representation of mobile class. What is mean by mobile class? See, actually class means it's a virtually it's there. Okay, really it is not existing. For example, all are virtually no. See, we are creating a variable int a, so that int a is really existing, which means it's it creates it has a memory. Okay, computer allocates a memory for that variable int a. Okay, so that variable a has allocated, a is allocated with a memory. Similarly, an object will have a memory, but class will not have a memory. Okay, a class is just a representation. Okay, just a representation, but the implementation of class is by the object. Okay, let's consider what else a class contains. It contains some variables or attributes and behavior. I told properties, isn't it? So that properties we are specifying in the class, and behavior we are specifying in the class. Both we are specifying in the class, which means an attribute and the behavior of an object we are specifying using a class. So here the class mobile. Mobile has an attribute such as model, IMEI. It should be IMEI, not IMSI. IMEI, color, weight, and then camera pixels, mobile status. All these are the properties or the attributes of a of an object. Okay, that's we are specifying in the mobile class. Then its function also or its behavior also specifying in the class, such as dial number, start call, end call, take picture, and so on. Okay. Okay, we can say class is just a blueprint. Okay, you already know the meaning of blueprint. So class is the blueprint of an object. Okay, that's why we are specifying all these details in the class. So this is the syntax of creating a class type variable and object of that class. So mobile space my mobile will create a variable which is my mobile of mobile type. Then using the second line we are assigning the address of the address of an object of mobile type. Okay, using the new keyword or new operator. So I hope you could understand. This figure 5.7 represents how to create an object of mobile class. See, this box is actually what the object address. Okay, here we are stored the real object. Okay, so this real object has some properties and behaviors, that is model. This object has a model, IMEI number, color, weight, camera pixel, and mobile status. So address of this object, suppose 25b, this is the address. So this address will be copied to the variable of that class type, which is my mobile. Okay, so that this all will be, so this object we can create using the new operator. Okay, and see here using a single line, in a single line we are creating a class type variable and also assigning the object of that address of the object to that variable. Okay, see here several objects are created, as you can see here. See, my iPhone X, that is a variable of type mobile. My Samsung, my BlackBerry, these all are a variable of type mobile, but all these are different objects. This is one object, to a second object, third object. Okay, each object has its own properties and its own values. Its own properties means properties will be same. Okay, which means like my iPhone X has a color, but my Samsung also has a color, but value is different. Similarly, BlackBerry has color, value is different, isn't it? Either suppose smartphone is red, sorry, my iPhone is red, Samsung is blue, and BlackBerry is black. Okay, so see, both these three objects has the property color, but values is different, isn't it? So this my iPhone X has one model, but my Samsung has another model, and my BlackBerry has another model. Each one has its own values. Okay, so that is meant by object. Okay, then dot operator. So in order to access the dot operator, in order to access the members of the class, such as if you want to know the color of my iPhone X, how can you get? You have to use the dot operator. For example, my iPhone X dot color will give its color. Then my iPhone X dot its weight or dot model will give its model or color. Okay, so using the dot operator we can access member variables. Which are the member variables? See, this model is a member variable, like in the previous figure we have seen. Okay, see here. So we have to create an object of this class mobile. Then using that object we can call, suppose okay, let mobile m. Okay, then m equal to new mobile. Okay, so now m has the address of this mobile class. Okay, so I implemented that class in an object. Okay, so this m is not the object, m is a variable of class type, but it stores address of the object. Okay, then if I know the model of this m, how can I get m dot model? The same value, the capital M should be used. So m dot model will give its model of m, and m dot color will give its color. Okay, like that we can access the properties and behavior of a class using the dot operator. Okay, so I hope you could understand what is dot operator. Okay, one example is given. My iPhone X dot color equal to black. My Samsung dot model equal to A5. Similarly, we can access its member methods and member variables like this using the dot operator. Okay. Then next topic we are going to learn is expressions. Students, expression simply means combination of maybe constants, and then operators, variables. Okay, so according to the type of variables and type of constants used in the expression, the type of expression varies. Okay, so simply expression means combination of variables, then operators and constants, that is known as expression. And in an expression we are using different types of different types of operators, such as arithmetic, relational, then logical, and so on. Different types of operators also we will use in an expression. Okay, then there are different categories of expression. First we are going to learn arithmetic expression. So from the name we can understand arithmetic expression means it will have arithmetic operators, isn't it? So arithmetic expression, of course, it will have arithmetic operators with constants and variables. Okay, then again arithmetic expressions are divided into several. The first one is integer expression. Okay, so integer expression means it will have integer constants and integer variables with arithmetic operators. Okay, so arithmetic operators comes with integer integer variable and integer constant, that is known as integer expressions. So example is written here. See here in this line, int a comma x comma y comma z length breadth. How many variables are there? 6 variables of int type. So in an expression there will be only integer variables. and integer constants with arithmetic operators, that is known as integer expression. For example, 23. 23 is an integer constant, so that is a integer expression. Then a plus 5, here 5 is an integer. A is also of type int. It is defined here, isn't it? Then length into breadth. Length and breadth are of type int, that you can see in the previous line. Then 2 into x plus 5. Then how can we solve this expression? By depend on the precedence and associativity. Okay, depend on the precedence and associativity of several operators, we will evaluate any expressions. But this is known as integer expressions because this integer expressions contains arithmetic operators with integer constants and integer variables, that is known as integer expression. Then next one is real expressions. So from the name we can understand real expression contains arithmetic operators with real variables and real constants. Okay, what do you mean by real? Like float and double, float variable and floating point values. Okay, in real expression contains arithmetic operators with float or double type variable and floating point numbers or floating point values. Okay, then see in this example here you can see 6 variables are declared of type float. Okay, then some examples are given. See 23.0, this is a real number, isn't it? So of course it is a real expression. Then 2.3 into x plus y. So what is the data type of x and y? Float. So of course it is a float variable and comes with floating point value. So this is an example of real expression. Length and breadth is of type float and x and y is also of type float. So it comes with 3.0 and arithmetic operators. So this is known as real expression. And next one is mixed expression. From the name we can understand what is mixed expression. Combination of real and integer expression are known as mixed expression. So it may have it will contain arithmetic operators with real constant, then real variables, then what? Then integer variables and integer constants. Combination of all these are known as mixed expression. For example, see here we have 6 variables, 3 variables of type int and another next 3 variables of type float. And see in this example 2 into x plus y. X is of type int, y is of type float, and we have an integer constant. So this is a mixed expression. Okay, I hope you could understand the differences between these three. So this is known as arithmetic expressions. Arithmetic expression contains arithmetic operators with uh, real variables, real constant, integer variables and integer constants. Okay, then next one is string expression. From the name we can understand string expression contains some operators with string values. Okay, string value, as you can see, it is given in double quotes, isn't it? So string value is given in double quotes. Okay, and with an operator. So we can perform only one operation with the string values, which is string concatenation operator. Okay, so concatenation operation. Concatenation itself is an operation performed using an operator which is concatenation operator, that is you can see here ABC in double quotes plus DEF in double quotes. So the result will be a joined value or concatenated value which is ABC and DEF together. Okay, so that is known as string expression. The next one is Boolean or logical expression. So this Boolean expression contains Boolean values with arithmetic and relational operators. So students, here you can see several examples. See, midterm grade. Midterm grade is a variable, so that midterm grade contains a value. So that midterm grade equal to B in single quotes. So this is a relational expression. Okay, let me underline that. See students, this is a relational expression. What is the output of this expression? That can be either true or false. Okay, Then there is another operator, logical OR. We have learned logical OR operator, isn't it? And this final grade is also a variable which has some value that can be a or any other value. If this final grade variable contains the same character which is a, and this relational expression will give true. When it will give true, when final grade contains the same character, that time it will give true. Okay, and when both, for a logical operator, if both expressions are true, then output will be true. And if for logical operator, if one of the expressions is false and another one is true, then also output will be true. Okay, then similarly it will have a boolean values. Okay, see, this is true, this is false, true, true. Similarly, if an expression contains boolean values, that is known as boolean expression. See, I equal to j, whenever the value of I and j, suppose value of I is 1 and value of j is also 1, so this expression I equal to j is true, isn't it? So the result of this expression is true. That is known as boolean expression. I hope you could understand. So students, here we have some expressions. We need to write its corresponding Java expression. Here we have a mathematical expression that we need to convert to Java expression. See, 5x cube. So it is, we cannot use x cube in Java. So instead of x cube, we can rewrite x cube in Java as x raised to 3 equal to x multiplied. This operation should be used. You cannot see. Let me write this one first. X into x. So this is how x into x into x. This is how we can write x cube in Java. This is mathematical expression. This is Java expression. But you cannot write like this, x into x into x. See, this into expression is not valid. This symbol is not valid in Java. So which operator we can use for multiplication? This is the right one. Okay. Then 5x cube plus 2y plus y. This we can rewrite as, how can we rewrite 5 into x into x plus 2 into y into x plus y. So the same. This is how we can rewrite a mathematical expression as a Java expression. Then the second one, a plus b into c plus d. So here we have parenthesis. So the same parenthesis we can use. What we have to add here, just need to add a multiplication symbol here. So like a mathematics, in mathematics it means multiply, isn't it? But in Java it's not possible. It will make syntax error. So we have to use a multiplication symbol. Okay, I hope you could understand. We can go to next page and let's see what is in the next page. Okay, some examples are given. Then ax square plus bx plus x. So a into x. For x square we have to multiply like this, x into x. Then b into x into c. Then x divided by y plus z. How can we rewrite it as? So we have x divided by y. So division operator is this, isn't it? Not like this. Then plus z. So how can we evaluate this one? We will check for the precedence and associativity. Then of course this one has the highest precedence and this one has the lowest precedence compared to this operator. So x divided by y will be performed first and that value will be added with z. So that will be the end result. Okay. Then example 5, t equal to 2m1 m2 divided by m1 plus m2 into g. So how can we rewrite this as? We can rewrite this as 2 into m1 into m2 divided by m1 plus m2 then multiplied by g. Okay, so here we can use bracket, isn't it? Better to use bracket. If you are not using bracket, then also no problem, because based on the precedence and associativity we will evaluate, isn't it? Then the next one is a into h plus v square by 2. So there is an m, e equal to m into. So here we need to add multiplication symbol, otherwise it will not be detected as multiplication in Java. So add here multiplication symbol, then a into h plus v square. For v square, how can we write v square? V into v, then divided by 2. So the complete form you can see here. Okay, students, next topic is type conversion. Okay, so type conversion means uh, sometimes we may need to copy value of one variable to another variable, okay, of different type. For example, we may need to we may need to copy value of a float variable to an int variable. Okay, so that time some error may occur. Okay, so we cannot copy directly because the size of the data types are entirely different. For example, you already know the size of the byte data type is very less than size of the int data type, isn't it? So suppose if there is a variable byte a int b, so if you try to copy a equal to b, we what is this means? B is like a big room. Okay, this is B is like a big room and A is like a small room. Okay, there are several people here. Okay, in this big rooms. So we are trying to accommodate this number of people in a small room. So it's not possible, isn't it? So this room can accommodate only 5 people. This can accommodate 50 people. So we are trying to accommodate 50 people from this large room to a smaller room. So that will make an error. Okay, so some mechanism we have to use to perform, but this should happen. A equal to B should happen. A is of type byte, int is of type what type int, sorry, B is of type int. So like we are trying to do like this, the same operation we are trying to perform here, like A equal to B. So but it should happen. So in order to make this happen, we are using type conversions. Okay, so let's see. There are two types of type conversions: implicit type conversions and explicit type conversion. Okay, so implicit means it's known as automatic type conversion. Okay, so automatically the type conversion will happen. For example, when automatic type conversion will occur, whenever there is a, see here you can see byte, short, int, long. Okay, this is 1 byte, 1 byte, 2 byte, 4 byte, and this is 8 byte. This is the size of each data type, isn't it? So this one type, like this is the room space, and this is the room space of this short, and this is the room space of int, and this is the room space of this long. So you can see the size differences. Okay, so there is a long variable, byte variable a, short variable b, int variable c, long variable d. Okay, so whenever we are trying to copy value of a to b, so the statement is like this: b equal to a, which means it's like a big room and it's small room. So here how many people? 5 people are there. Here we can, means this room can accommodate 5 people and this room can accommodate suppose 10 people. Okay, so it can easily, this value of a we can store in b, because it's like this room difference. So the people in the room a can be shifted to people in the room b, because the size of the room b is bigger than uh, size of the room a. So room b can accommodate the people in a, so that will happen. So this will not make any error, which means this step b equal to a will not make any error. So this kind type of conversion is known as implicit type conversion, or automatic type conversion. Okay, so that is known as implicit type conversion or automatic type conversion. The example I can show you. Okay, here you can see long long number, my result. What is the data? What is the size of long data type? Which is 64-bit, isn't it? 64-bit and 64-bit or 4-byte, both are same. Previously I told in byte, and now we are considering bit. Okay, let it be anything, both are same. 4-byte equal to 64-bit. 4 into 8. 4-byte into 8 equal to okay, this is not 4-byte, actually int is 4-byte. Sorry, what I have written earlier. Okay, let me check. If I written wrong, I can rewrite. Okay, so that has gone. Okay, no problem. So I think I have written like this only. Int, size of int is 4 bytes. Okay, size of long is 8 bytes. I think I have written like this, 8 bytes. So 8 byte means 64 bits, isn't it? Which means 8 into 8, that is 64. Okay, then which means what is mean by byte and bits? 1 byte equal to 8 bits. That's why this is 64 bits. Similarly, 4 bytes is equal to 4 into 4. Sorry, 4 into 8, 32 bits. So here long is higher data type than int. So what operation we are performing? My result of type long. My result equal to long number. So long number plus int number. Okay. So higher data plus lower data will be higher data only. That we are trying to store in my result. Okay. So this will perform automatically. Like this is big room, this is small room, and this is a big room. Okay. Here this room can accommodate suppose 10 people, and this can accommodate 5 people. Okay, but actually here are 2 people, and here are suppose 4 people. So 4 plus 2 6, 4 plus 2 6. So 6 people can accommodate. Now the result is 6, but the maximum is 10. So 6 we can store in long, isn't it? So here will be 6, not here. Okay, so the entire result will be 4 plus 2 6. So this can accommodate 10 people, but the result of this 4 plus 2 is 6 people. So we can accommodate here. Okay, but if it is if my result was of int type, what will happen? Only 5 people we can accommodate. So 6 is a larger value, so it will make an error. Okay, so I hope you could understand. This is an example of implicit typecasting. Okay. So here the pictorial representation is given. You can check that. Then we can check the example too. So here we have some variables of different data types: my double, my result, my float, my int, my char. Okay, in my result, that is double type. So what is the data type of, what is the size of double data type? 64-bit, isn't it? Then we are trying to store my int, the sum of my int, my char, my float, and that divided by my double will be stored in the my result. So my result is of the largest data type, isn't it? That is double. So it will perform. So this is known as an implicit typecasting. Okay, we are not using any an additional step to perform this operation, isn't it? So you can, if you have any doubt, you can write down the data size of each data type, and you can compare. Okay. Then next we are going to learn explicit typecasting. So explicit typecasting means like if you want to store, okay, let me write something. Say we have an integer variable a, okay, and we have a long variable b. If you want to see, if you consider that example, this is like a small room, this is a big room. Okay, so we can accommodate. So this here there are the size of this room is 5. Only 5 people can accommodate, and this can accommodate 10. Okay, now there are 7 people. Okay, there are 7 people are there. Here there are 2. Okay, so if I copy A equal to B, which means it's telling like we are going to shift the people in B to A. Like the size of the room A can accommodate, the size of the room A is 5, size of the room A is 10. But we are trying to accommodate 7 people in A. So it will make an error. So in order to make it possible, we will perform some operation, isn't it? So by performing that operation, we can accommodate, okay, by doing something. So that is known as explicit type conversion. Okay, so we will use an operator. Okay, using that operator we can perform this one. Okay, that is known as explicit type conversion. Okay, so this is overall it is known as typecasting. There are two typecasting, implicit type and explicit type. Implicit type is automatic one, we don't need to write any steps, but for explicit type conversion we have to use an operator. So let's see which is that operator. Okay, students, here you can see there is a variable of type int, which is A, and here we have 7.45. But actually in a variable of type int we can store only 7, isn't it? But if you try to store 7.5, this will make an error, isn't it? So this will make an error. So we have to do something in order to store like this. Okay, so that is known as that operation. So this by performing this operation we can accommodate this value in the variable A. Okay, so this is the operator used for explicit typecasting. Here why we are using int? Because here we will use the target data type. Target data type. What is the target data type? Here we are going to store in A. So what is the data type of that variable? That will be the target data type. Suppose the value of let it be long A equal to 7.5. Okay, so what data type we should use here? The target data type should use here. The target data type is the data type of that copy that variable, which is long. So here we should use long. Okay, so but which value will be copied in that variable A after performing like this? Only 7. Anyhow, if you are trying to store 7.45, the decimal value will be neglected. Okay, only the integer part can be stored in the variable A. So after performing this operation, if you try to print value of A, it will print 7. Okay, not 7.45. 0.45 will be neglected. Okay, then let's consider another example. Float x equal to 8.25 f. Okay, here this f means to represent it is a float value. Okay, then int y, and y equal to of int x. What is the value of x? 8.25. That we are trying to store in a variable of type int. Okay, so you know the size of float and int is same, which is 32-bit. So you may consider here why it is not, why we are using explicit. It may size of float and int are same, which is 32, but there is another difference. The range is very high, isn't it? So you can check in the previous chapter. The range of value can accommodate in an integer variable is smaller than the range of values which we can accommodate in a float variable. So that's why float is considered as a largest data type than int. So among float and int, which one is higher? Which one is larger? Float is larger. So that's why we are using explicit typecasting here. Okay, and here we are using the target data type because the data type of y is int, that is the target data type. That target data type we are used as the operator. Okay, here we have some program. Okay, write a program to demonstrate float into explicit conversion. Okay, so public class float to int, public static void main means here we are defining the class, define the main method. Then the same example, see, same steps are written here. Then if we try to print the values of x and y, see, already value of x uh, is defined, isn't it? Which is 8.25. So when we print value of x, the same value will print. But here, this explicit type conversion will remove this decimal value, or after what we have in this after decimal, what value we have, that will be neglected or truncated, and the only integer part will be stored in the variable of type int. Okay, so that's why the result of y is 8. Okay, then let's consider this integer division. Here we have some variable of int type, sum and count with the values, then double average equal to sum divided by count. Okay, so students, here we will store what value we can get in the variable average. So if you consider the division operation, actually 60 divided by 80. Okay, what will be the result? We need to add 0 first, because we cannot accommodate 80 in 60. So what we will do, we will add a decimal part, then 600. Okay, then how many times? So 7 times, isn't it? So 40. Okay, so this value, this division will be continued. So see, so approximate value, the approximate result of 60 divided by 80 is 0.7 something. Okay, so students, here 60 and 80 are stored in an integer variable. So here sum divided by count. So this will considered as integer division. So what will be the result? Only 0 will be the result. Okay. So the result of this expression will be 0 because of the integer data type. Okay. So that 0 is copying to the variable average. Okay. When 0 is copied, the result will be of double type, which will print 0, 0.0. Okay, so I hope you could understand. Then we have program 5.16, a program where incorrect results are produced due to implicit conversion. Okay, the same which I explained above. Then a program demonstrating the use of implicit conversion to get correct result. We have the variable sum with the value 60. Then we have int count equal to 80, the same variables of the same type int. Then double average equal to of double sum divided by count. Okay, so here using an operator, so that then we are getting the correct output. Why? Because here performing explicit typecasting. So explicit typecasting will not remove the decimal part. It will include both integer part and a decimal part, which is 0.75. Okay, so students, I think it's the last topic. Okay, this is the last topic. Difference between println function and print. Here we have uh, two print functions. One is println and one is print. Okay, so students, so here you can see this println function. Println function print its argument. Here we have the argument method. So whatever we have in message, that will be printed in the current line. After printing that value, cursor is going to the next line. So I will show you the example. Let me to open the BlueJ. So students, here I opened BlueJ, and here we have a demo class and define the main method. Okay, then we are going to use print function system.out.println. we can have something like hi. Okay, close double, then one more time, hello. Okay, so here we can use print function. We got error message, so let's check what value it will print. See, hi and hello in different lines. How in different lines? Because the first function is println. How println is working? What is the argument? That is hi. So hi will be printed on the current line, which means in the first line. Okay, first line means whatever where the cursor is remaining. So in that place the argument will be printed. So hi is printed. Then after printing that argument, cursor is going to the next line. Okay, then coming to the next statement, which is also a print function. So that print function prints the argument in the current line. Okay, both are printing in the current line, but the difference is for println, after printing that argument in the current line, cursor will go to the next line only for println. And if we print one more time, if we print something hi here also, let's see what will happen here. See, after printing this line, okay, cursor is sorry, not cursor, it's printing the argument hello. Now cursor is in the same line, means in this position. Okay, after this o, cursor is there. Now after executing ninth line, hi will be printed next to hello, isn't it? So we can check where hi will be printed. See, hi will be printed next to hello. And if you print one more time hi, so here we are using a println function. So where it will print? So now where is the cursor? Cursor is here after this hi. Okay, in this position, after this I, cursor is there. So the function of, or the working of println is print the argument on the current line, means where the cursor is. After printing that argument, go to the cursor, go to the next line. Okay, let's check, compile and execute. Okay, see, I hope you could understand the working of print and println functions. Okay, let's see some examples. Okay, then program 5.18, print example 1, then first line, second line. See, that is the argument. Both are print. So what is happening? On the same line, both arguments are printing. Here there is a space, that's why here we can see the space. Okay, then program demonstrating the println function. Okay, this example you can check yourself, because already I explained, isn't it? This also explains println functions. Here we have a variable roll number with a value 23. Just if we want to print value of a variable, we do not use double quotes or single quotes, isn't it? We can directly use, okay, we can directly use that variable only. Okay, let's that one more example I can show you here. Suppose here we can declare a variable int a equal to 10. Okay, so if I want, see, for printing hi is a string, but here I need to print value of a variable. So we do not use like this, like a. So it will not print value of a, it will print a only. Okay, so but what we need to print value of a. So simply we have to use a. So what it will print? We can compile. We got compiled and we can run. Okay, so don't worry, already compiled. So 10. See, here you can see 10 is printing. That is a value of a. So I hope you could understand uh, the topics which we discussed today. So if you have any doubt, you can send message in WhatsApp. Okay. So thank you, students.